Hi everyone, welcome to this YouTube channel. Today we're looking at NECO 2023 final solution. NECO July 2023 chemistry alternative A chemistry practicals final solution. You can see the question part 1 says answer all questions. Number 1 says all bullet readings in initial and final as well as the size of your pipette must be recorded, but no account of the experimental procedure is required. All calculations must be done on this question paper. A is a solution containing 0.04 mole per dn cube tetra orthosulfuric acid. B is a solution of anhydrous sodium triazocarbonate 4. Put A into the burette and titrate against 20.0 cn cube or 25.0 cn cube of B using methyl orange as indicator. Repeat the titration 3 more times and record your result below. We'll have the format, the volume of pipette use equal to, they'll have the table, titration, final burette readings in cn cube, initial burette readings in cn cube, volume of acid in cn cube, the rough column, first 1, 2, and 3. We'll go to the question. A, 1AI says calculate the average volume of acid, II, which of the solutions has a soapy feel. Then the equation for the reaction given to you, H2SO4 plus sodium carbonate giving us sodium sulfate plus water plus CO2. Then BI says from the results and information provided, calculate I, concentration of B in mole per dn cube, II, concentration of B in gram per dn cube, III, mass of sodium trisulfuric salt that would be formed if 1.0 dn cube of B were neutralized by A. Then IV, volume of CO2, carbon dioxide, that will be liberated at STP. Before we go to question 2, let's look at the solution to question 1. So looking at the final solution, the volume of pipette used is usually 25.00 cn cube. Then we have the results, titration, final burette reading, initial, and volume of acid used. On the rough column, the final burette reading is 21.30, initial 0.00, volume of acid used, which is 21.30 minus 0, giving us 21.30. On the first column, the final is 23.00, initial 2.00, then the volume of acid used 23 minus 2, giving us 21.00. Second column, 31.00 minus initial, final is 31.00, initial 10.00, then volume of acid used 31 minus 10, giving us 21.00. Third column, the final reading is 36.00, initial 15.00, then we'll have a volume of acid used at 21.00. So everything depends on the endpoint you're using in your own school. Then going to AI, our VA is 1 plus 2 plus 3, adding up the titer values of 1, 2, and 3, and dividing it by 3. So that will give us 21.00 plus 21.00 plus 21.00 as we have there, divided by 3. That will give us 21.00. Mind you, the rough was not used. So that is AI, the volume of acid used. Then AII says, question AII says, which of the solution will have a soapy fuel? The answer is solution B. That is the alkaline solution, the sodium carbonate solution. Then BI says we should find the concentration of B of the base in mole per dn cube. We have the values we need itemized there. Our CB is unknown. Our VB, our MB is 1 mole. VB is 25. CA is 0.04. Then VA 21.00. NA is also 1. Or NA and MB are for the balance equation. So now applying the titration formula and making CB the subject. CB equal to CAVA MB all over VB times NA. Then substituting the right values, 0.04 times 21 times 1 all over 25 times 1. And solving out for CB, our CB is 0.0336 mole per dn cube. BII says we should find the concentration of B in gram per dn cube. Concentration of B in gram per dn cube, which is written as rho B or PB, is equal to concentration in mole per dn cube CB times relative molecular mass. So we have to find the relative molecular mass of sodium carbonate. Solving it out, we have 23 times 2, taking the atomic mass of sodium as 23, carbon as 12, and oxygen as 16 times 3 atoms. We now have 106. Then solving, our rho B becomes, or the concentration in gram per dn becomes 0.0336 times 106. We have 3.56 gram per dn cube at the concentration of the base in gram per dm cube. Question BIII says mass of sodium tetrasulfate 6 that will be formed if 1.0 dn cube of solution B were neutralized by A. We go to the solution. We have the reaction, the equation for the reaction written above there. Then we'll have to find the molecular mass of sodium sulfate, and that gives us 142. 23 times 2 plus 32 plus 16 times 4, 142. Then from the balance equation, we see that 1 mole of H2SO4 produces 1 mole of sodium sulfate. Therefore, 0.04 mole of H2SO4, which is the molar concentration of the acid, will also produce the same 0.04 mole of sodium sulfate. So the concentration of sodium sulfate is 0.04 mole per dn cube. Then mass of sodium sulfate per dn cube becomes the concentration times relative molecular mass, which is 0.04 times 142, and that will give us 5.68 gram per dm cube. Going to question number 1BIV, we are asked to calculate the volume of CO2 liberated at STP during the reaction. First of all, we'll find the number of moles of that seed in the average titer using the formula mole equal to Ca times Va over 1000. So solving that, we'll have 0.04, which is our Ca times 21 over 1000, giving us 0.00084 mole of H2SO4. Then we'll move the balance equation. We see that 1 mole of H2SO4 liberated 1 mole of CO2. So we'll now go back. 1 mole of H2O4 gave us 1 mole of CO2. Therefore, 1 mole of H2O4 also gave us 22.4. Since 1 mole of a gas is equivalent to 22.4 dn cube at STP. Therefore, 0.00084 mole of H2O4 will now give us 0.00084 times 22.4, and that will give us approximately 0.0188 dn cube of CO2 gas, or 18.8 cn cube of CO2 gas at STP. So we now move to question number 2. Says candidates are advised to adhere strictly to the instructions given. All observations and inferences must be recorded in the table below. Identify any gases or gas given off. You are provided with sample C. Carry out the following test on it. Serial number AI says place the sample C on a dry spatula and heat on a flame. The observation and inference column is vacant, are vacant. Then AII says C plus 5 cn cube of distilled water and shake thoroughly, observation and inference column vacant. Then divide the solution into two portions, observation and inference column are vacant. Then BI says to the first portion add barium chloride, observation and inference column vacant. Then BII said add dilute HCl to the product from BI, observation and inference column vacant. Then III to the second portion add phenolphthalein, observation and inference column vacant. So we'll go to the solution now. So we'll go to the solution to number 2. We'll have AI. Play the sample C on a dry sample spatula and heat on a flame. The observation C burns, giving out a golden yellow flame. Inference sodium ion present. II second test says C plus 5 cn of distilled water and shake thoroughly. Observation C dissolve completely to give a colorless solution. Inference C is a soluble salt. Then the third one, divide the solution into two portions. That is just a command. There will be no observation or inference into that particular command. We'll go to the next question. BI. To the first portion, add barium chloride solution. Observation, white precipitate formed. Inference, bicarbonate, sulfite, sulfate, or sulfide ion present. BII says add HCl to the product in BI. We have brisk effervescence, a colorless, odorless gas evolve. Gas turn lime water milky, and moist blue litmus paper faint red. White precipitate dissolve to give a colorless solution. Inference, gas is CO2. Triose 4 ion, CO32 minus confirmed. Then BIII. To the second portion, add phenolphthalein. Observation, a pink color is observed. Then inference, C aqueous is acidic, is alkaline or basic. C aqueous is alkaline or basic. So go to question number 3. Question number 3, AI says name two gases that can dechlorize potassium heptaoxodichromasis. 3AII says state two changes that will be observed when dilute hydrochloric acid is added to ion filings. III. To prepare a standard solution of anhydrous salt, mention 3 apparatus required. Then B says state what will be observed when 2 drops of methyl orange is dropped into a solution of lime juice. Sulfur oxide gas is bubbled through solution of ion 3 chloride. Then ethane 1,2-dioic acid is added to a solution of potassium triosocarbonate 4. We go to the answers now. So the solution for 3A, number 3AI, hydrogen sulfide and sulfur oxide. The gases that can dechlorize potassium heptaoxodichromasis are hydrogen sulfide and sulfur oxide. Then 3AII, the question is which state what we observe when dilute hydrochloric acid is added to ion filings. 2 observations to be made. So 3AII, first is brisk effervescence, colorless, odorless gas, which gives pop sound with lighted, you can say lighted or you say burning splint evolved. In bracket, the gas is hydrogen gas. Then Number 2, the iron filings gradually dissolves to give a pale green solution. So that's observation made for 3AII. Then 3A triple I says we should mention the instrument used for preparing standard solution of a anhydrous salt. So the instruments will have a kind of standard volumetric flask, stirrer, chemical balance. So that instrument that can be used to prepare standard solution of anhydrous salt. Then 3BI says, state what you observe on adding meteorange to lime juice. Lime juice is acidic. So when you add meteorange to it, the lime juice will turn red. Then 3BI, that lime juice turns red, 3BI. Then 3BII says, what we observe on bubbling sulfur oxide through iron 3 chloride. Iron 3 chloride has reddish brown color or yellow color. So the observation is going to be reddish brown color will turn, or the solution will turns green. Reddish brown color or the solution turns green because SO2 is the reagent to iron 3. Iron 3 chloride is reduced from reddish brown to green iron 2. Then number 3 says 3B triple I says what you observe when you add ethane 1,2-dioic acid to potassium triosocarbonate 4. So observation, we're going to have brisk. We're going to have effervescence. We have to remember the word brisk because that is organic acid. So depending on the concentration, you don't have to say brisk. So effervescence, colorless, odorless gas, which turns lime water milky evolve. And of course, you know the gas is carbon 4 oxide. So good luck and stay connected to this channel.